Hello friends, welcome back to my channel. So my name is Pramod Thorat and welcome to the course How to Pass CompTIA A+ certifications. So before you start, don't forget to subscribe this channel to see more video like this. So let's go to the model 2 for this series. So this is the model 2 bus systems, motherboards and BIOS. So we can check in the model is differentiate between the different bus structure, differentiate between motherboard and components, their purposes and the properties, and configure and apply BIOS settings. So let's check the bus structure in this model. So what is the bus structure? The bus structure is the channel or path between the components in a computer is called a bus structure. Computer components are incredibly complex, so all parts must communicate in a fast and efficient manner. If not, the speed and capabilities are lost. Move to the next slide. Typical bus structure. So typical computer has two key buses: system bus, shared bus. First one, the system bus, local bus or front side bus connects a microprocessor, central processing unit and a system memory. And the shared bus connects additional components like ISA, EISA, PCI cards, USB, firewire and PCIe together through a bridge. A part of the computer as a chipset acts as a traffic cop, integrating the data from the other buses to the system bus, lets multiple devices access the same path to the CPU and the system memory. So let's move to the next slide. And the next slide is for the typical bus structure. So you can see in a picture there are two bridges. First one is a north bridge and second one is the south bridge. The illustration shows how the various buses connect to the CPU, central processing unit. North bridge controls the CPU, memory and AGP, and south bridge controls everything else. So let's move to the next slide. So in this slide we can see the buses types. So every bus has three components. Bus types are address bus, data bus and control bus. So description of the address bus is a unidirectional pathway, which means the information can only flow one way. And database, a bidirectional pathway for data flow, which means that information can flow in two directions. Control bus carries the control and timing signals needed to coordinate the activities of the entire computer. So let's move to the next slide. So in this slide we can check the industry standard architecture bus structure. So still be found in some newer computers, largely unchanged since it was expanded to 16 bits in 1984, become a bottleneck to performance and was augmented with additional high-speed buses, persist because of the enormous base of existing peripherals. So in this slide we can see the extended industry standard architecture EISA bus structure. So extend the ISA bus to 32 bits, allows more than one CPU to share the bus. Bus mastering support enhanced to provide access to 4 GB of memory. EISA can accept older ISA cards better suited to bandwidth intensive tasks such as disk access and networking. Most cards were either SCSI or network cards. So let's move to the next slide. In this slide we can check the peripheral component interconnect bus structure. So Intel introduced in early 1990s these bus structures, a hybrid between ISA and VL bus, provides direct access to system memory for connected devices, uses a bridge to connect to the front side bus and CPU, is capable of higher performance while eliminating the potential for interference with the CPU. So PCI structure like CAN bus connects up to 5 external components, can have more than one PCI bus on the same computer. PCI bridge regulates the speed of the bus independently of the CPU speed, half of the CPU speed, provides a higher degree of reliability, ensures that PCI hardware manufacturers know exactly what to design for. So let's move to the next slide. And the next slide is for the accelerated graphic bus structure, AGP bus. So 32-bit wide, same as PCI card, runs at full system bus speed, doubles the bandwidth of the port, does not share bandwidth with the other devices. An AGP bus structure's base speed is 66 MHz, 2x modes double the speed of the bus, can also get AGP at 4x and 8x speeds. 8x expansion slot has a clock speed of 533 MHz, uses spatial signaling to allow twice as much data to be sent over the port at the same clock speed. So let's move to the next slide. The next slide is called the PCI Express. So PCI Express created to replace the AGP and PCI, backwards compatible with PCI, has 1x, 4x, 8x and 16x slots. Multiplier indicates maximum transfer rate. Full duplex serial input-output architecture. 133 MHz 64-bit, has the highest transfer speed of any expansion slot. So let's move to the next slide, the motherboard in a computer system. So what is the motherboard? So let's check. Everything in the system plugs into it. It's called motherboards. Everything is controlled by it, depends on it to communicate with the other devices on the system. Is the largest printed circuit boards. Every device has one. Houses the CPU, the controller circuits, the bus, RAM, expansion slots of additional boards, and ports for external devices. Determines capabilities and limitations of the systems. So main components on a motherboard. The first one is system clock, CPU, chipset, RAM, ROM BIOS, CMOS configuration chip and its battery, system bus with expansion slots, ports directly on the board, power supply, connections. So let's check what is the system clock. The system clock keeps the beat of motherboard activities. Frequencies measured in hertz determine the speed of the CPU. So what is the chipset? Chipset determines how system hardware interacts with the CPU and other components, determines system performance, determines system limitations, establishes how much memory can be added on motherboard, determines the types of connectors on the motherboards. Chipsets are divided into two distinct components, north bridge and south bridge. The north bridge controls access to the RAM, access to the AGP video card, access to the CPU, the speed of the CPU can communicate. South bridge controls a communication between the CPU and expansion ports, hard drive, sound card, USB ports and other input-output ports. Let's move to the next components. The component is expansion slots. So expansion slot is access printed circuit boards. Common expansion slots are peripheral component interconnect PCI, accelerated graphic ports, peripheral components interconnect express PCI cards. Next component, riser cards. Used to physically extend a slot so a chip or card can be plugged in. Card resides parallel with the motherboard, used in low profile and space saving cases. So let's check the other slots, AMR and CNR. AMR is an audio module riser, AMR, and CNR is a communications and networking riser. So added LAN and home networking functions, a 3-pin interface, accommodate two format making various audio modem and audio network combinations possible. So let's move to the next slides. So how to identify the motherboard components? If you can see on the screen, there are multiple components are present in the motherboards. That is 4-fit connector, ATS power connector, RAM socket, CPU sockets, primary ID connector, secondary ID connector, front panel connections, AGP slots, PCI slots, mouse port, keyboard port, USB 2.0 connectors, serial ports, parallel ports, sound card jackets. Also the auxiliary CPU power connector, difference for AMD and Intel. This is the basic components and this is the basic motherboard structure in your computer. So let's move to the next slide. Let's see the front panel connectors. So you can see the front panel connectors group and the front panel connectors. So attached to the motherboard with pins are always grouped together but maybe in a different order or configurations. The power LED may be neither or 2 or 3-pin connectors. Can buy adapters to change the configurations. The reset jumper must be attached in order for the computer to start. May also see USB, firmware and audio. So let's move to the next slides. So what is the BIOS in your computer system? Basic input output systems. So BIOS is the basic input output systems, also known as the system BIOS or ROM BIOS. Holds the firmware of the motherboard. The fundamental purpose is to initialize and test the system hardware components and load the operating system. It is the first software run when powered on. Provides a consistent way for applications and operating system to interact with the keyboard, display and other input output devices. So let's move to the next slide. Next slide. So BIOS contains a built-in diagnostic like the power on set test post, built-in monitoring tools like temperature, fan speeds, intrusion detections, voltages, clock, bus speeds. And BIOS can be accessed at system power up by a particular key functions, usually delete or F2 functions on keyboard. User can configure hardware options using the keyboard and video displays. Software is stored on a non-volatile ROM chip on the motherboard, specially designed to work with each particular model of computer, interfaces with devices of the system. Also known as ROM BIOS or firmware, supports different features as depending on the manufacturer of the chip, can be upgraded by using a process called flashing. Contents is stored on a EEPROM chip so that the contents can be rewritten without removing the chip from the motherboard. Allows BIOS software to be easily upgraded to add new features or fix bugs. What is the difference between the BIOS and CMOS? It uses a battery pack complementary metal oxide semiconductor CMOS chip to hold BIOS settings. Has a menu based user interface to make changes to the settings. The user can configure hardware using the BIOS and CMOS, set the system clock time, enable the disable system components, visualization supports, voltage parameters for CPUs and memory, set the boot sequence, controls fans, and set various passwords. So let's move to the next slide. So BIOS can be manually reset back to the factory defaults by removing the battery for a few seconds, moving the reset jumper to enable, then start the computer. So as of 2011, the BIOS is being replaced by the more complex Extensible Firmware Interface EFI or the Unified Extensible Firmware Interface UEFI. Specification that defines a software interface between the operating systems and components replaces the BIOS firmware interface initially made for the Latinum architecture, now available for x86 and 64X platforms, provides legacy supports for BIOS services, can support remote diagnostics and repair of computers even without an operating system. So let's move to the next slide. So protecting documentation and configuration settings. So keep well label, return record of all changes you make to CMOS, records of hardware and software installed, network settings, keep documentation up to date and in safe place, document before you flash or replace the BIOS chips. So let's check the summary for this module. In the module we discuss common types of buses and how they operate, motherboard components and their functions, BIOS and CMOS function. So you have completed this module. Study hard, good luck, and thanks for watching. Please don't forget to subscribe the channel to see more video like this. So I will upload next part shortly. Thanks for watching. Thank you.